Hello learners, welcome to today's session. This is a part of Diploma in Smart City Development and Management course, which is diploma offered by School of Engineering and Technologies. Today's session I am going to talk about introduction to smart cities, then role of data science and big data in smart cities. Briefly, I will be talking about what is a data science, what is the role of data science, and how the big data is going to contribute for smart city contribution. Then briefly I will be talking about how big data tools can be used for fast data to deep insight, and followed by different challenges and issues in smart cities. And finally I will be concluding. So let's start with what exactly the smart cities people talk about. According to the United Nations, by 2050, 68% of the world population is going to live in urban areas. It means what? It means there will be a tremendous growth in the digital ecosystem of the organization. The discipline of data science focuses on the processes of collection, integration, processing of large amount of data to produce useful decision-making information which will be useful for informed decision-making system. If you look at the definition given by Wikipedia, smart city is a technologically modern urban areas that uses different types of electronic method and sensors to collect specific types of data. Information gained from the data is being used to manage assets, resources, services efficiently. In return, the data is used to improve operation across the city. So data has to be collected from different part of the sources. It could be from World Wide Web, it could be from different part of digital libraries, or it could be from any personal databases or scientific databases. So when the data has to be collected, it has to be pre-processed and then store it at one place where the big data and database technologies are going to help you. So let's understand what exactly the data science is. So data science is a multidisciplinary science with an objective to perform data analysis to generate knowledge that can be used for decision making. And when we say multidisciplinary science, it actually constitutes of different part of computer science, statistical research, mathematics, machine learning, data processing, and most importantly, the domain expertise. And this is how the complete data science is going to be constituted. And further, this knowledge can be in the form of similar pattern or some kind of predictive planning model or forecasting model, etc. So basically, a data science applications collects data and information from multiple heterogeneous sources, cleans, integrate, processes and analyzes this data using various tools and present information and knowledge in a various visual form. And after that, the decision maker can take the decision. Let's look at the different definitions from the practitioner point of view. According to Helverian from Google, data science can be defined as the ability to take data, to be able to understand it, to process it, to extract values from it, to visualize it, to communicate it, and that's going to be a hugely important skills in the next decades. So when we talk about data science, not only we have to understand how we are going to collect the data, how exactly we are going to extract the values, how we are going to visualize it, and how exactly we are going to communicate it so that decision can be taken. Let's understand the role of data science and big data in smart cities. If you look at the diagram, we have a different applications starting from healthcare, transportation, power grid, energy, smart education. Every single application is generating huge amount of data. And when the data is being generated, these data can be in the form of structured data, this data can be in the form of unstructured data, or this can be in the form of semi-structural data. So let's understand the different areas in which the data science can be useful. It helps in making business decisions such as deciding the health of companies with whom they are planning to collaborate. It may also help in making better prediction for the future, such as making strategic plans for the company based on the present needs or present trends. It may also help to identify similarities among various data patterns, leading to applications like fraud detection, targeted marketing, etc. So in general, data science is a way forward for the business decision making, especially in the present day world where the data is being generated at the rate of zettabytes or maybe more than that. Let's understand the big data now. The term big data has been used since 1990s. And some people give the credit to John Massey for using the word for the first time. Big data usually includes data sets which beyond the ability of commonly used software. And most of the time the traditional database softwares, they are not able to capture, they are not able to manage or process these huge amount of data. So basically, big data technologies requires a set of techniques with new form of integration to reveal deep insight from the data set that are diverse, complex, and of a massive scale. So basically, there is no single definition to define big data. Big data is also a data, but usually with a huge size. Big data is a term where we use to describe a collection of data that is huge in volume and yet growing exponentially with time. And in short, such data is so large that complex that none of the traditional data management software such as your basic SQL or basic DBMS tools are not able to store it or process it efficiently. So you need a better management tool which can not only store the huge amount of data, can also help it to process it. According to Wikipedia, big data is the term for a collection of data sets so large and complex that it became difficult to process using hands-on database management tools or any traditional data processing application. Big data philosophy encompasses unstructured, semi-structures and structured data. However, the main focus is always on unstructured type of data. The trend to larger data set is due to additional information which is derivable from analysis of a single large set of related data, which allow some kind of correlation to be found to spot business trends, to determine quality of research, to prevent the diseases, which can link legal citation, which can combat crimes and determine real-time roadway traffic conditions. So this is how the big data technologies can help us to take better decisions. Another definition of big data by Gartner in first quarter of 2011, which has been published in Teradata magazine. Big data exceeds the reach of commonly used hardware environment and software tools to capture, manage and process it with tolerable elapsed time for its user population. Another very good definition from the paper by the McKinsey Global Institute in May 2011, big data refers to the data set whose size is beyond the ability of typical database software tools to capture, store and analyze it. After understanding what exactly the data science and what exactly the big data, let's understand what is a model of generating and consuming data. So if you look from the old model, the model of generating, consuming data has actually changed. In the previous model, few companies were generating data, whereas all others were actually consuming that. But with the new model, all of us are actually generating data and all of us are consuming the data. So everyone is generating and everyone is consuming the data with a new model. Let's look at the rise of big data and harnessing big data. So if you look at the diagram, there are three important technologies starting from OLTP, OLAP and RTAP. OLTP, which stands for Online Transaction Processing, OLAP, which stands for Online Analytical Processing, which is a part of basically a data warehousing technologies, and RTAP, which is a real-time analytics processing, which is today's big data architecture and technologies. So if you look at the diagram, in 1968 or early 70s, people were actually using operational databases. All the decision was taken based on the day-to-day data. People were actually reporting, and based on those reporting, human analysis on historical data, they were actually able to take the decision. Then in 70s, mid-70s, relational databases has come into the picture where the data was stored in the structured form. Then in mid-80s, between 80s to 90s, the concept of data warehousing has come into the picture. In data warehousing, people were actually storing the data in a historical form, so that they can take a better decision. And based on those historical collection of data, people were actually taking the decision. Then in somewhere in the 90s and 2000, people were also using stream computing, they were using data mining techniques, people were using business intelligence techniques to actually process the huge amount of data. But if you look at real-time analytics processing, where most of the data are in motion, you are actually collecting the data and these data are being generated in the real time. So actually sensors are responsible for generating huge amount of data. Now let's look at the big data analytics. So when we say big data analytics, let's first understand what is analytics. So analytics is a broad term which is covering 4 different pillars in the modern analytics model, starting from descriptive analytics, diagnostic analysis, predictive analysis or analytics. Finally, we have a prescriptive analytics. In a descriptive analytics, what have we done in the past? That is what exactly we are looking for. In case of diagnostic analytics, why have we seen the data in the past? And where exactly we are going to use and when exactly we are going to use? This is what we do in predictive analytics. And finally, in a prescriptive analytics, how should we take the action based on the derived patterns? And each of these 4 different pillars plays an important in how your business can better understand what your data reveals and how you can use those deep insights to derive business objectives. Let's map between the different types of analytics and computational tasks. As I mentioned in the descriptive analytics, which describe what happens. So basically we use the reports, we use the basic statistic techniques like a mean, median, variance, count, distinct, or sometimes we also use the linear algebra for computational part. We use PCA techniques, we use linear regression techniques for what exactly happened using descriptive analytics. In case of diagnostic analytics, why did it happen? So we use different queries to retrieve those answers. We use different data mining techniques to extract those patterns, and for that we use different techniques. We use different similarity between the different pairs of points. We use the nearest neighbors techniques. We use the clustering techniques. We use SVM techniques for that. Sometimes we also use the graph based search. We use shortest path techniques. We use minimum spanning tree techniques to find out why did it happen. In case of predictive analytics, what is likely to happen? So we are doing some kind of simulation, we are doing some kind of forecasting where we used different distance based similarities. We use different graph based techniques. Not only that, we also use some kind of optimization techniques. We use some kind of integration techniques. We use Bayesian techniques to actually find out what is likely to happen in the future. And finally, we have a prescriptive analytics. What can we do to make it happen? So we use some kind of planning techniques. We use some kind of optimization techniques where we use some kind of linear programming. We use quadratic programming. We use gradient descendant techniques to find out what can we do to make it happen. So after understanding different types of analytics and computational tasks, let's look at what exactly the big data analytics is. So according to me, the big data is more real-time in nature than traditional data warehouse applications. In traditional data warehouse application, we usually store huge collection of data, which is historical collection of data. But in case of big data, which is most of the time is a real time. And traditional data warehouse architecture, for example, we have a Exadata or Teradata, are actually not well suited for the big data application. We use shared nothing environment. We use massively parallel processing techniques. We use scale out architectures which are well suited for big data applications. So if you look at the graph, we have a x-axis, we have a time in months, and in the y-axis we have a cash flow. So you can see that how much data has been generated as compared to the big data applications. Big data analytics has contributed a lot of cash flow. Let's look at the big data characteristics. So big data is basically defined using three different important characteristics, that is 3 V's. One is volume, another one is velocity, and third one is varieties of data. So when we talk about volume, that means we are talking about size. So if you look at the diagram here, we have y-axis where we have given the data from megabytes to the petabytes, and in the x-axis we have given the increasing data varieties and complexity. So if you look at the first part where we have given the different enterprise resource planning applications, where the data was actually generating in terms of megabytes or maybe up to few gigabytes. Then we have a CRM based techniques where we were using the customer relations management. We were using the support contacts, and they were also using few gigabytes to between terabytes. Then we have a web applications where we have a web log data, where we have a dynamic plotting, we have a alliance networks, we have a search marketing. All these were generating huge amount of data. But when exactly we have come into the big data era, we have a lot of data sources, starting from different sensors, different devices, different mobile devices, different social media stream clicks, different sentiment analysis. All these are responsible for collecting or generating huge amount of data. So big data technologies, if you really look at, there are only two things to address. The first one is the storage part, and the second one is how exactly you are going to process it. Let's look at these important big data characteristics one by one. The first V stands for volume. That means we are talking about the scales. We are talking about how the data volume is increasing exponentially. So if you look at 2009 to 2020, the data has been generated from 0.8 zettabytes to 35 zettabytes. And this is growing by the factor of 44 times. That means if you really look at the tweets per day, there are nearly 300,000 tweets every single day. People are actually generating a lot of data. That means there is an exponential increase in the how the data is being generated, how the data is being collected. If you really look at the different survey, 2.5 quintillion bytes of data is being created every single day. That means how exactly you are going to store these data. So big data is actually responsible for that. There are other sources where the data is being generated. Facebook users shared nearly 4.16 million pieces of content. Instagram users like nearly 1.73 million photos every single day. YouTuber users actually uploads around 300 hours of new video content every single day. Like that, there are many different data sources which is responsible for how the data is being generated. So big data is actually responsible for how this data is going to be stored and finally process it. Let's look at another very interesting example of how the data is being generated, that is volumes. So EarthScope, which is the world's largest science project, which is designed to track North America's geological evolution, and this observatory records data over 3.8 million square miles, amassing 67 terabytes of data. So what it does basically, it analyzes seismic slips in the San Andreas faults. Not only that, it also plumbed of magmas underneath Yellowstones and much more data. So you can understand that how much the data is being generated. Second V, which stand for varieties. As we mentioned earlier, there are varieties of data where the big data is going to store, starting from structured data, semi-structured data, and then unstructured data. And we know that big data is actually responsible for unstructured type of data. So we have a varieties of data, starting from relational data, where you have a data in the form of tables, you have a data in the form of transaction, legacy data, you have a data from the World Wide Web, you have a data in the form of text, you have a XML data, which is basically a semi-structural data. You have a graph data starting from your social networks, you have a semantic web. Not only that, you have a streaming data which you can only scan the data once. You have a health data, you have a weather forecasting data, you have a online data, you have a finance data. So there are huge varieties of data which has been generated and has to be collected at some point, and then further it can be used for the further decision making process. So basically, whenever we want to extract the knowledge, all these types of data need to be linked together. And that's the reason the data pre-processing plays a very, very important role. Any of the data science project, any of the machine learning project, any of the data mining project, whenever we says that the data is being generated, collected in the different sources, but when you are actually collecting, transforming, cleaning, all this has to be performed so that one can extract the patterns or one can extract the knowledge from these different varieties of data. Now look at the single view to the customers. Like one person, you can see that how much data he actually generates or contributes. A single person who is a customer, basically he is a customer of banking finance. So he has a credit cards, he has a bank account. So every day he purchases something, he transfers some amount, he go to the social medias, he goes to the gaming zone, he also generate the data using different entertainment sites starting from Netflix, Amazon. Then he go to the different sites where he can purchase the different products, starting from Amazon to Flipkart and so on. And all these single person generates a huge amount of data and different varieties of data. The third V's, which stand for velocities, which is speed. So what happened? The data is being generated very fast and that has to be processed very fast. In case of online data analytics, if we miss some kind of decision, that means we actually miss some kind of opportunities. You must have experienced this, like whenever you are looking for something, now immediately whenever you visit the site, you get some kind of promotion. So based on your current location, based on your current purchase history, the companies would like to send some kind of promotion right now, some store next to you. Or there are some health monitoring tools where the sensor is monitoring your activities and body temperature, or any abnormal behavior can be alert, can give the alert to the users. It means if any abnormal behavior is being monitored or is being observed, the immediate reaction can be given to the persons or to the doctors so that they can take some kind of decision. Because if we don't take the decision on time, that means we are missing some kind of opportunities. So when the data is being generated fast, it has to be processed very, very fast. So real-time data which are very, very fast in nature. We have social medias and networks. All of us are actually generating data. We have a different scientific instrument which is collecting all sort of data, starting from your weather data, you have a vehicle data, you have a different RFIDs, different sensors. You have a different mobile devices which is tracking all objects all the time. You have a different sensor technologies and network which is measuring all kinds of data. So the progress and different innovation is no longer hindered by the ability to collect the data. So there are many ways by which the data is being generated or data is being collected. But by the ability to manage, analyze, summarize, visualize and discover knowledge from these collected data in a timely manner, in a scalable fashion is what the big data technologies are going to do. And some author even has make it to the 4 V's. Instead of volume, velocity and variety, they also talk about veracities. That means they are talking about data inconsistencies. That means they are talking about the data qualities. Because unless you have a good quality data, you don't get good quality results. So whenever the data in doubt, there might be many reasons for that. There may be faulty instrument data collection. There may be some kind of data drop in the while you are transferring data from one network to another network or one source to another source. So you have to perform the different kind of data pre-processing techniques. Now look at the different data tools, which is fast data being generated and how the fast data is being generated to the deep insight of the data. How the knowledge can be extracted from these huge amount of data. So if you look at the below bottom part of the diagram, you have a different sizes where we have given the terabytes, petabyte, exabyte and zettabytes. So different techniques were used for generating or collecting fast data. So we have ETL technologies, we have ECL technologies, we have Teradata, we have Hadoop technologies, we have MapReduce technologies, which is actually responsible for generating or collecting huge amount of data. And when we talk about big data analytics, there are many tools starting from Hive, we have what we call Mahout, we have a MATLAB, we have a SPSS, we have a SAS. There are various tools which actually helps you to visualize the data or extract the data from these huge amount of data. And when talking about the deep insight, that means you have some kind of BI techniques, we have some kind of social media analytics, we have some kind of sentiment analysis technique, which is actually helping you to deep dive into the data and extract the meaningful information from those huge data. And finally, it should meet your business objectives. And based on the type of applications you are working on, you can actually extract the useful information from those big data. Now let's look at the different challenges and issues in the smart cities. Different challenges could be starting from data sources and different data characteristics, or we have a data and information sharing. The challenges could be in the form of data quality or in the form of security and privacy. So when we talk about data sources and different characteristics, we know that nowadays the characteristics of the data have changed. In the beginning, somewhere in the 1970s, most of the data were structured data, where you were storing the data in the form of tables, you have rows and columns. Now that has changed from structured to semi-structured or unstructured type of data. And managing these various kinds of data can actually pose a very serious challenges. And in the context of smart city application, utilizing big data could be a big data collection. How exactly you are going to collect the data? Once you have collected the data, how you are going to compile these complicated data? How you are going to categorize, organize, and finally access these data in a better way. So these are the different challenges which one has to sort out whenever they are working on data science related project. Coming to the second challenge and issues, it could be from information sharing or data sharing, because we know that most of the government and city agencies or city department typically work in the silos. They maintain some kind of confidentiality in terms of public information. They can't give the data to everyone. And this is applicable within any smart city since there are many sectors or many industries involved. So smart city application will need to find some ways to prevent or reduce the barriers to achieve seamless information sharing and exchange among different entities. It could be starting from different stakeholders, starting from customers to the one who is actually taking the decision, or it could be a government servant. And when we talk about data quality issues, the data is captured by the different peoples and under different regimes and stored in a distinct databases. And they can store the data in the very different formats. The actual problem comes when you are actually combining the data for implementing one application. For example, if you are working on a smart cities project, so you might have a data which you are collecting from the transportation department, which you might have a data which you might be covering the data from MCT departments, or there might be some data which you may be collecting from the pollution departments, environmental departments, right? So when you are collecting these data, and all of these different agencies might store the data in a very different format, and actual challenges come when you are combining these data, and that can cost you to the data ambiguity or trustworthiness. So actual data quality issues comes when you have a data, you have a missing data problem, you have a data in the real world are very noisy, and that time these challenges really make it very difficult. So whenever anyone is working on smart city related project using data science or big data analytics techniques, one has to ensure that the data which we are storing, which we are collecting, are actually quality data, because unless you have a quality data, you don't get the quality results. Another issue is what we have is security and privacy, and this is actually related to when you are sharing the information. You are sharing the data, and data captured by the different people under different different agencies may include some kind of confidential information which is actually related to the government and people, and they need some kind of high level of security policies or some kind of mechanism to protect these data against unauthorized use and malicious attacks. So there has to be a policy when we are finally going to deploy, or we are finally going to use the data science or big data techniques in a smart city application. So today's session we actually talk about what is the role of data science and big data in smart cities. Briefly, I have discussed about how the data science can contribute and what exactly the data science is. We understood that data science is a multidisciplinary approach where not only you take the data from one sources, you constitute the fields from the machine learnings to different statistical techniques to the domain expertise. After that, we also talk about different big data characteristics, where we try to understand the 3 V's especially. We try to understand what is a volume, what is a velocity, and what is a variety related problems. So according to me, big data is a problem, right? So why this is a problem? Because you have a huge amount of data. The data is being generated and collected every single day, and we have shared different examples. You have a social media, you have a different sensors, you have a mobile data where the data is being generated every single day, and huge amount of data is being generated. And there has to be some kind of storage device which can actually take all these data. And another problem we addressed was the velocities, where we said that because these data are being generated very fast, So it has to be processed fast. So big data technologies such as Hadoop is one such technologies which not only store the data, it also help you to process the data in a efficient way. Third V's we have addressed, that is varieties of data. We mentioned that the data has moved from structured data to unstructured data, and big data techniques mainly address on unstructured type of data, right? And when we talk about unstructured type of data, and not only that, when you are storing the data, you have a data source from the different varieties of data. And when you are taking the meaningful knowledge from the data, all these varieties of data has to be linked together. This has to be pre-processed together, and then finally take the decision. And finally, we saw the different big data tools, starting from fast data to big data and analytics and deep insight. What are the different big data related tools which can actually help you to generate or collect or monitors or some kind of technologies which can actually help you to store these data or process these data. And finally, we talked about different challenges and issues in the smart cities, which is starting from data source and different characteristics, data and information sharing and data qualities, and security and privacy issues. So whenever someone is trying to implement the smart city project using different software techniques like a data science and big data, one has to ensure that the different policies are there so that this can be implemented efficiently. So that's all for today's session. We'll meet in the next session. Thank you.